Hi everybody and welcome to a new video in the Generative Music AI course. Last time we saw a brief history of generative music. Today we're going to look at generative music use cases. In particular, I'm going to give you the tools to classify different generative music systems. Then we're going to delve into some samples of industry use cases. And finally, I'm going to quickly touch upon different business opportunities out there currently associated with generative music. Let's dive into it. In order to classify a generative music system, I suggest we ask ourselves a number of questions regarding the system. First, what's the goal of the system? What's the ultimate generative goal of the system? So a system could be used to generate a melody, a chord progression, a full-blown track, perhaps for a jazz improvisation line, perhaps for a drums or a bass line, or perhaps for generating loops or sounds. At the same time, there's another type of goal, and that is associated with the ultimate musical domain of the generative music system. So perhaps we can have a system that generates music for video games, or perhaps for movies, or for advertisement, for concert music, pop music, or music for social media. It's a very casual type of music. So you can have a combination of these two sort of groups in order to determine the ultimate goal of generative music system. So you could have a system, for example, that generates full tracks for movies. And so that is the ultimate goal of a generative music system. Now, next question we should ask to pinpoint a generative music system is, who's the user of this system? Well, there are many users that can actually use different generative music systems. So certain more professional generative music systems will be used by composers, by producers, by songwriters. So these are a type of music assistants, composer assistants. But we can think of other generative music systems that target different types of users. Like, for example, developers. So this is an API that generates music, and a developer can leverage it in order to get music in his or her video games or web apps or what have you. Then there may be researchers who are the ultimate targets, the ultimate users of generative music system. It could be consumers, for example, people who use social media networks, or marketing agencies. So you have a generative music system that's targeted at ads, and the ultimate user of that system could be a marketing specialist. Next up, we can ask, how autonomous is a generative music system in its generative process? And I think we can think of this question in terms of a spectrum. On the left end of the spectrum, we have human-machine co-creation and collaboration. So here, the machine and the human user are really intertwined and work together in order to create something musical. But then the more we work our way towards the right-hand side of this spectrum, and the more the machine takes over. At some point, we are going to have humans who are going to be mainly supervisors, where they're perhaps going to just like revise the music generated by a generative music system, or they can just have like a minimal amount of input. Towards the extreme right-hand side of this spectrum, we have generative music systems that are fully autonomous. These systems generate music by themselves with almost zero input from a human user. Next up, we should ask, how is music generated? And I'm not going to get too much into the details here, because we're going to have a video lecture on this topic in a few days, and that's all about the different generative techniques that we can leverage to generate music. And we're going to be talking about deep learning, machine learning, rule-based systems, generative grammars, all of this kind of stuff. But here it is important to just mention that this is an extra dimension that is worthwhile to explore when we want to classify a generative music system. Next, we have the final question that I have for classifying a generative music system. That is, how is music represented? So is it represented as audio, as a spectrogram, or as a symbolic representation like MIDI or other forms of symbolic representations that sort of remind us of a human score. Again, we're going to dedicate a full video on this topic because it's extremely important. So for now, I'll just leave it at that. So you have them, the 5 questions you can ask to classify a generative music system. Now, I'm going to take all of these 5 questions and I'm going to implement them on a couple of real-world generative music systems. So the first one is Melodrive, or was Melodrive, the generative music engine that I built with my company back in the day. So let's go through all the 5 different questions and answer them so that we can classify Melodrive. So what was the goal of Melodrive? Well, the goal of Melodrive was to generate music or generate full tracks for video games, and these tracks would change their emotional state in real time. In terms of the user, our ultimate user were developers who could use a simple SDK to integrate reactive music in their video games. Melodrive was fairly autonomous because it was able to generate music on the fly by itself. However, developers had to constrain its generation, passing on in real-time information about the emotional state of the music, as well as other information like instrumentation and style. But all in all, it was more of a human supervision kind of thing rather than something more interactive between the developer and the generative system. We used a bunch of different techniques to generate music, and we divided the compositional task into a number of different subtasks, and for different particular subtasks we used different techniques. But to simplify everything to an extreme degree, I would say that we used a lot of rule-based good old-fashioned AI as well as machine learning. In terms of the musical representation, we were mainly dealing with a symbolic generation. So we were manipulating symbols, or we had our own representation, symbolic representation of music that we used to generate music itself. Let's do the same exercise with Aiva. Aiva is a generative music company. Let me show you their website real quick. So here you can see it. And the tagline is your personal AI music generation assistant. Aiva's goal is to generate full tracks for background music. Its users are mainly composers, people who know how to manipulate music. And the reason why that's the case is because the level of autonomy of Aiva is, I would say, quite shifted towards the left. So, of course, there's a lot of generation that Aiva does in a complete autonomous way, but then there's a level of human-machine collaboration and interaction. So the target, the ideal customer for Aiva is somebody who knows his or her way around music and can manipulate the music generated by Aiva. I'm not sure about the generative techniques that they use because, of course, these are proprietary things, but I would assume they use a mixture of deep learning and rule-based approaches. And then in terms of the music representation, they definitely use a symbolic approach. So by the end of the generation, you're going to have a sort of MIDI score that you can then manipulate however you want and then you can produce. We've seen a couple of examples where I showed you how to use the system for classifying generative music systems. Next, I want to show you a few different generative music use cases that are on fire right now in the music industry. First, text-to-music generation. We've already encountered this in previous lectures, but just to remind you what this is all about, with text-to-music generation systems, we have a system that gets textual inputs, descriptions of music in text, and then it generates music based off of that initial description. The music that's generated, I would say, could be used, well, not just the music, but this text-to-music generation systems can be used by people on social media who have very little understanding of music. The level of human input in text-to-music generation is quite minimal, because all you need to do really is craft an intelligent prompt, and that's it. In terms of the techniques used for this type of systems, all of them are deep learning based. They use transformers, variational autoencoders, and all sorts of very advanced deep learning techniques. The representation used for music tends to be audio based, even though we start with audio and then there usually are some intermediate representations where there are systems which sort of extract embeddings of those initial audio waveforms that we have. But all in all, I would say this is definitely on the audio side. There are different examples of text-to-music generative systems. The most relevant ones are MusicLM, MusicGen. I'm going to cover MusicGen in this course. There's also MuBert. And as for MusicLM, as mentioned in a previous video, I've already covered MusicLM in a dedicated video, and I'm going to leave you this video up here. Another use case that's on fire right now is singing voice cloning. What's that? Well, it is what it says it is. Basically, you have an algorithm that's able to reproduce the singing voice of a target artist. And you can use that for, I don't know, like for example, having a piece of music, your piece of music with the voice of Britney Spears, for example. So who are the users of this type of technology? Well, I would argue this tend to be producers and wannabe musicians and producers who want to use like this famous artists' voices for their productions. There's definitely a level of human-machine collaboration here because the output of these systems is not perfect, and so you definitely have to sort of edit the output and use a lot of production tips and tricks to solve the inherent issues that we still have with this type of technology. In order to generate voice or cloning voice, we tend to use deep learning, advanced deep learning techniques, and we definitely go for an audio representation. Here it makes a lot of sense because we really don't care that much about the notes themselves. Well, of course we do care about that, but we care perhaps even more about timbre and all of those particular nuances of the voice in terms of performance and production that can only be captured with an audio representation of music. Arguably, singing voice cloning has been one of those technologies that has driven a lot of attention towards generative music. And the reason is because there have been instances of songs which were hijacking the voice of very prominent artists. For example, this song called Heart on My Sleeve that used a fake Drake and fake The Weeknd voice went viral on TikTok, and Universal Music took notice of that, and all the other major players, the labels, took notice of that because this literally threatens the IP, the copyright of these huge music labels and of course of the artist. So there's a lot going on around singing voice cloning right now in terms of like the technology itself, but also in terms of the legality of it and ethical implications. And I'm going to give you an example of this. So this is a song which was created by a producer using fake vocal of Grimes. Grimes being this independent artist. The difference with the previous case is that Grimes came out and said, well, it's totally fine that you use my voice. Only thing, if you do use my deepfake voice, we're just gonna share revenues so that I'm gonna get like 50% of it, and you, the producer, are gonna get like 50% of whatever you make with your song using my voice. And Grimes pushed this idea even further, and she released a website with some backend technology with singing voice cloning that allows people to generate Grimes deepfake vocals. so that they can use them. So this is a very smart way of taking advantage of these new technologies that are going to be there no matter what. Now, let me show you the results of these deepfake vocals, and let's listen to this. Right, so you get the point. It's quite impressive. The voice works really, really well. Another use case that I find really promising at this point is instrumental accompaniment. What is that? Well, you sing, you now have a vocal line, and you want to add some background music to that vocal line. So you want to create an accompaniment, an instrumental accompaniment for that vocal line. So that's what automatic accompaniment is all about. This technology, I think, is targeted mainly at amateur musicians who mainly use their voice to come up with a song line, and then they want to add some music behind it. But it could also be used as a sketch tool for people who just want to experiment different musical implementations of a melodic idea. The level of collaboration between the human and the machine, I would argue, tends to be like quite advanced, because you definitely have to input a lot of information into the models, the generative models, in order to get the accompaniment that you really want. You can use all sorts of technologies to come up with an automatic accompaniment system, from rule-based systems all the way up to the most advanced deep learning models. In terms of representation, most of the time I've seen symbolic representation for automatic accompaniment. So at the end of the day, you're going to get like a sort of score, and then you can produce that. But sometimes there are also audio-based automatic accompaniment models, even though I think they tend to be way more rare. Newton is an interesting company that does automatic accompaniment. It's also particularly interesting because it came out from the first iteration of the Sound of AI startup accelerator that we had earlier in 2023. Let me show you their website. So here you see they have an app, and it's basically a smart music sketchbook app where they, among the different features that they have, there's also the possibility for people to create an accompaniment on their vocal lines. If we move down from music composition at large and we look at its constituents from a production kind of view, we can see that there are a lot of generative music models that focus mainly on sound synthesis. They use AI to synthesize sounds. And the ultimate goal of these models is to create new types of sounds that sometimes are completely alien, I would say. The target users tend to be professional producers and mid-level, mid-experienced producers. The level of human-machine collaboration is quite a lot, because you have to explore these models in order to craft the sounds that you really want. The main generative technique used for these models is deep learning. The main representation for these models is obviously audio. The reason is quite simple. We have to retain as much information about timbre and performance as well as production nuances as possible, and the only way to do that is to work directly with audio or one of its transformations, like for example spectrograms. Let me give you a couple of examples of sound synthesis models using AI. One is NSynth. It was published a few years back by Google. Let's listen to what this model can do. It's quite interesting. NSynth comes up also with this hardware thing, and here you see that you have like 4 different sounds, and you can slide between all of them with a finger, and the sound is going to change and morph from one sound to another. Another example of a sound generation system is very dear to my heart, and it's the result of a project that we had with the Sound of AI community called Open Source Research. We built a voice-to-sound synthesizer that leverages AI. In other words, you can utter a vocal command, like for example, give me a Jimi Hendrix guitar with a lot of reverb, and the model would pick up on that description and create a sound that hopefully will reflect the initial vocal input. Open Source Research was a community-driven research project. We had more than 150 people from the community collaborating at all times, and the project lasted for a couple of years, and it led to the publication of a paper at AIMC in 2022. So this one's the paper. You can download it from here. It's very interesting, the research that we carried out here. Let me show you some of the results in terms of sound. So this is the companion website for the paper. Right here you have the vocal inputs, and here you can hear the results. So the vocal input here is a noisy percussive guitar. Okay, and down here there are also other sounds that are way more alien, like for example, very low attack, very high decay, no low mid, max high, mids, and high. So yeah, the model was super interesting, and you can experiment with that because we have a live website that you can use to play around with it. After this quick review of a bunch of different use cases in generative music, I want to show you the business opportunities that I currently see for generative music. Specifically, I want to show you the different opportunities for different types of companies. On the one hand, we have tech giants. On the other, we have startups, so generative music startups. I do believe that music democratization will come from tech giants. What do I mean by music democratization? Well, I think all of those large text-to-music models like MusicLM from Google or MusicGen from Meta, those will be leveraged within social media by large tech companies like TikTok or Meta itself, or perhaps Google, and they will democratize music creation. And the reason is quite straightforward, because all of a sudden people, users of social networks, will be able to generate music for their Instagram story or TikTok in a very simple manner, perhaps just inputting a very simple prompt, just like we can do right now with MusicLM. But in order for that to happen, I do believe there's a need for a demand, and that demand will come only from these large social media platforms. On the other hand, startups can fight back on a different level altogether. Rather than approaching music democratization, so this huge text-to-music models that entail a lot of computational power and a lot of music, very huge data sets, they can tackle a different type of problem that's mainly targeted at musicians. They can build intelligent tools for musicians. We already saw an example of this with Newton. They're building this really cool music sketching app leveraging AI. And so here I see a huge potential to elevate the possibilities of musicians, providing them with very useful tools which are going to enhance their creative possibilities. Okay folks, we are at the end of today's video, and before I dash off, I just want to remind you about the main points that we covered. First of all, I provided you with a system to classify generative music systems, and this is based on 5 different questions you can ask to pinpoint a generative music system. The first one is about the goal of the system. The second is about the user of the system. Then we interrogate ourselves about the autonomy level of the system, and then we can ask ourselves what are the generative techniques used by the system and what is the type of music representation used by the system. We also covered different use cases for generative music systems, and indeed we saw that generative music systems come in different shapes and different colors. Finally, we've analyzed the generative music business opportunities of different types of companies, and we saw that while startups probably are going to change the way musicians operate by injecting on the market new tools, music creative tools that will help musicians and producers elevate their creativity, tech giants will probably have the opportunity to democratize music creation at large by leveraging their large audiences and using models like the ones we saw. So like, for example, musical M, in other words, text-to-music generative systems. By now, you should have a good understanding of the history of generative music as well as the different use cases of generative music. Next, we'll take a look at the ethical and legal implications of generative music. Thank you very much for your attention. I'll see you next time. Take care.